We're going to talk today about finding domain and range by looking at a graph. We're going to talk about finding increasing, decreasing, and constant portions of a graph. We're going to talk about odd, even, neither functions. And I don't know what else we'll look. But if you guys look, if you have a graph, domain is what value? X value. Range is what value? Y. So if you have an ordered pair, this is really easy to see. But your X values, if I look here and I say, what is the domain of this function? We always read a graph from left to right, just like you read a book. So the furthest left that I am on this coordinate plane is what number? -1. So my domain here is from -1, and it goes all the way over to what number on the x-axis? 4. Now I write it like this because there are certain notations that you have to use. There's a difference between a closed dot and an open dot. There's a closed dot on -1. What does that mean? That the point is included. So how do I write that? With a parenthesis or a bracket, Sean?
The bracket.
Good, a bracket. And then on the other side, it's an open dot, which means it what? It's a parenthesis because it does not include. So this would be my domain for this graph. Domain is from left to right, same way you read a book. You guys are going to have to be able to look at a graph and see, okay, this goes on forever, this doesn't, this stops, where does it start, all that good stuff. If I had arrows at the bottom of this, what does that mean my domain is? It goes on forever. So if I read left to right, what's over here on the x-axis? What infinity is this? Negative infinity. So it would be -infinity to 4, something like that. I mean, obviously it's not, but I'm just saying you guys are going to have to see that and make sure that you can recognize that. If I'm talking about range, I'm talking about the y value. Range, we always read from bottom to top. Right? From bottom to top. So I look here. What is the lowest point on the y-axis that my graph is? -5. And then it goes up. What is the highest point? +4. What do you guys notice about both the dots at -5 and +4? They're both closed, which means I have what on either end? Brackets. Okay? Does that make sense? You guys with me on that? All right, so look here. What do you notice is on the end of your graph? Arrows. That means infinity. Guys, they're both going down. I understand that. But when you talk about domain and range, remember I said domain is left to right on the x-axis. So what, this is going on forever. That means the x values are going on forever. What infinity is over here to the left? Negative infinity. And this is going to keep on going and getting bigger to what? Positive infinity. This is the way you write negative infinity to positive infinity. We use a parenthesis because there is no specific stopping point. You cannot say this is the last number. It goes on forever, so we have a parenthesis. You guys could also say this is all real numbers. It's everything on the number line, on negative to positive. So if I'm going to read the range is from where to where? What did I tell you? But how do we read range? Lowest to highest, from bottom to top. So this is my negative infinity down here. This is my positive infinity. So look, this is continuing. It's starting down here. It's going up, 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 and it stops. The graph does not get any higher at what point? At 1. So it's negative infinity to 1. What goes on negative infinity? A parenthesis or a bracket? Parenthesis. And what goes on 1? A bracket. Does it include? Is there a point there? Yeah. The graph doesn't have like a big open spot or anything like that. It includes that point. If I look here, yeah, sure. If I look here, how do we read domain and range? Domain is where to where? Left to right. So my domain, what's the furthest left to the furthest right? -4 to what? +4. What goes on either end? Brackets, because those are closed dots. And then for range, we read from bottom to top, low to high. So this is the lowest point, which is what? 0. And this is the highest point, which is what? And what goes on either end? brackets. These are closed dots here, guys. Do you see this? Wait, what?
I'm confused on the range.
Mm-hmm.
Where'd you get the 0 from?
Because you read from bottom to top. So
Oh, yeah.
do you see how this is the lowest point right here?
Yeah.
And that's 0 in the y. That gets confusing, guys. I know that. You have to practice this. The graph stuff is sometimes can be very difficult, so we have to practice questions where you guys get confused. When we talk about algebraically, we'll talk about that later. We don't need that right now. But to test if something is a function, I told you yesterday, the vertical line test. Guys, this is super easy. You should want a ton of these on your test. The vertical line test, you put a vertical line straight up and down on a graph. If the line touches one time, that means there's only one x value for that y. What happens when I have ordered pairs and I have x's that repeat? It's not a function. So in this case, anywhere I draw a vertical line, how many times does it touch it? Just once. So then yes, this is a function. What about over here? If I draw a vertical line, how many times does it touch? 2. Look, that means there's an x value here, whatever it is. Say it's 3. That means there's an x value of 3 here, and there's 1 here. So if I wrote them as ordered pairs, they would repeat. So this is no. Vertical line test on a graph. If you draw a vertical line and it only touches once, yes, it's a function. If you draw a vertical line and it touches more than once, no, it's not. We agree? Okay. Okay, intervals of increase and decrease and constant. It is so important that you guys remember this. This slide, it says exactly what I'm about to say. It just says it in math terms. But what you need to write down, what you need to remember, what you need to memorize is this. You read increase and decrease on the x-axis. On what axis? The x. Intervals of increase, decrease, and constant is the x-axis. The y does not matter. My suggestion to you is when they talk about intervals of increase, decrease, and constant, I would cross out the numbers on the y just so you don't get confused. What I mean by that, if I put my finger on this graph, and how do we read a graph? Left to right. So I'm going to start over here on the farthest left side. And I'm going to follow this graph. What is my graph doing right here? It's decreasing. It's going which way? Down. Now, when I go from here to here, what's it doing? It's constant, staying the same. Then when I go from here to here, what's it doing? Increasing. You guys are going to be asked to look at a graph and say, what are the intervals of increase, decrease, and constant? How do we read intervals of increase, decrease, and constant on what axis? The x. Watch what I'm going to do. This is what I think all of you should do. I think when you see anything that has to do with intervals of increase, decrease, and constant, cross off the y. Now you can see the numbers that you're looking at. The interval of decrease. Where is this graph going down? From what number to what number on the x-axis? From -2 to 0. From -2 to 0, this thing is decreasing. And we always use parentheses on increase and decrease because you cannot increase and decrease at the same time. Like there's always that turning point. So it's always parentheses. But do you guys see? Some of you will look at this and you'll do it on the y-axis and it's wrong. It's only the x-axis. So cross off the letters on the y, or the numbers on the y. So if I look at my interval of constant on the x-axis, from where to where is this thing constant? 0 to 2. And then increase. Where is this thing increasing? From what to what? 2 to 4. Do you guys see that? Okay, it seems easy, I know. You will get this confused. We have to practice it a bunch. The graph may not always have all 3 intervals. It might just be increasing the entire time. From left to right, from negative infinity to positive infinity. That happens sometimes. But you always read intervals of increase and decrease and constant on the x-axis. So let's look at this. Okay, pretend this has arrows on it. We'll do this. Okay, how do we read a graph? Left to right. So I'm going to put my pencil on the furthest left of this graph, and I'm just going to follow the line. What is this thing doing the whole time? It's increasing. Is there an interval of decrease? No. Is there an interval where it's completely flat? No, it looks like it, but it's not. It's not completely flat. I'll show you when it's completely flat. So what is this thing doing the whole time? It's increasing. So I would say there's an interval of increase. And since there's arrows on both ends, it's increasing from what to what? Negative infinity to positive infinity. All right, so we're increasing and decreasing from negative infinity to positive infinity. So let's look at this next graph, okay? Let's pretend this has, that. Did I start it yet? Let's pretend that this has points, that it starts and stops. Like here and here. Draw it on there. We read interval of increase and decrease on what axis? The x. So see how they gave me two ordered pairs? What should I do? What do I think you should do when you're trying to read intervals of increase and decrease and you see y values? Cross off the y, just so you don't get yourselves confused. So now, put your finger, because some of us don't see this well, and that's fine. Put your finger to the far left, because we read a graph left to right. What is going on right here in the green? No. What behavior is happening? It's increasing. Okay, good. So we put an actual point there, so it's not going to be at negative infinity. What point is this on the x-axis? 2 probably about? Okay. Does it include 2 since I put a point there? Okay. And it's going up till we get to negative 2, I'm sorry. It's going up till we get to what x value? Negative 1. Does everyone see that? Oh, why did I put a bracket? My bad. Remember I told you guys always parentheses for intervals of increase and decrease? Not paying attention. All right, now I'm going to take my pen and I'm going to follow. What is happening from here to here? It's decreasing. So I have an interval of decrease from what x value to what x value? Negative 1 to 1. This is where you guys will get confused because you're going to get down here and you're going to say, well, that's negative. It's negative on the y, but where do we read interval of increase and decrease? On the x value. That's why I tell you to cross it out. Yes, sir?
Wouldn't it be like increasing infinite because...
Well, I told you guys to put a point there. Like actually put a point there and pretend that there's a starting and stopping point. If there were arrows, yes. But what's going on here now? From here to here, it is increasing, agreed. From where to where? From 1 to 2.
Please report to student services.
This is a concept, guys, that you absolutely have to practice because you will get this messed up. This is a major concept. So if you miss this, this is probably like 20 points off on your test. Intervals of increase and decrease and constant is super, super, super important for you guys to wrap your brain around. So we have to practice it. Again, listen to me. Listen. Put a point. Put right here at the end. I don't want to do negative infinity to positive infinity. I want to see actual points. We'll say that's negative 2 to positive 4. You guys see that? All right, so follow the graph. What am I doing here? I'm increasing. Look, I'm not going to cross off the y values. I'm going to leave it because that's what some of you guys are going to do. I am increasing from what to what on the x-axis? Negative 2 to 0. Does everyone see that? Okay, what am I doing then from here to here? It's constant. It's staying the same. It's flat. So it's constant from what to what on the x-axis? 0 to 2. Good. And then what's going on here? It's decreasing from what to what? From 2 to 4. If there were arrows in the end, your increase would start with negative infinity and your decrease would end with positive infinity. I know it's going down, but still, it's the x-axis that we're looking at. Super important that you guys remember intervals of increase, decrease, and constant is on the x. All right, we're looking here for relative minimum, relative maximum. We're not going to do a lot with this because you guys aren't using calculators. But relative minimum and maximum just means where the bumps are. You'll have a minimum and a maximum, the absolute highest, the absolute lowest. But when you have a graph like this, the relative just means like the ones in the middle. This would be a relative minimum because it's where? At the bottom or the top of the bump? At the bottom. This is a relative maximum because it's at the top. That's really all you need to know about that. Yeah, we don't need to know that. Piecewise. Okay, I talked to you guys a little bit about this yesterday. Piecewise functions, God bless you. Guys, when you talk about piecewise, it means a piece, not the whole thing. We talked about how to evaluate. Evaluating was pretty easy. We figure out where the parameters are. If I have my number is less than or greater than, whatever, that falls into this little category here. But when you are talking about piecewise, you're not looking at the entire graph. If I graph the line 2x plus 3, where are the only values that I care about, given the parameter that they said? Sean?
All the positive numbers?
Where x is what than 0?
Right. All the negative.
Negative. There you go. So look, this is how we're going to do piecewise. I'll do 1 or 2 of these, and then I'm going to make sure I get the whole lesson in here. So I have 2x plus 3. Well, most of us could graph a line yesterday or the other day on our quiz. What is my slope for 2x plus 3? 2 over 1, so it's a positive line. And where is my y-intercept?
3.
At 3. So I'm going to go over here. And at 3, I'm going to put a point. And I'm going to graph this line. My slope of 2 over 1. 2 over 1. It's positive, right? 2 over 1. 2 over 1. 2 over 1. You guys agree with me? Now, if I were to draw my whole line, pretend it's perfect, just like me. Just kidding. We have this beautiful line. But what is the parameter? What did our lovely book people tell us? The only values that we care about here are where? What is less than 0? X. The x-axis. So do you guys agree with me that right here on the x-axis is where x is 0? Where are the numbers on this blue line where x is 0? Or less than, sorry. On the left-hand side. So this is the only part of the graph that we want. You would erase the other part. You just want a piece of this line, not the whole thing. You guys see that? One more thing we need to pay attention to. What is this sign? Less than. Just less than, right? Or is it less than or equal to? So what kind of a dot should I have right there?
No.
Does it include or not? It's an open dot at 2. You guys see that? Yes? No? I don't want the whole line. I just want a piece of it. So you graph a line, you graph a parabola like you would any, and then you have to look at the parameter and say, okay, where am I looking? Where do they want the values to lie? If I look at the second one, 3 minus x. Well, let's rewrite that. If I have 3 minus x, I could rewrite that as negative x plus 3, correct? Agreed? Okay, so what's your slope here?
-1.
Negative 1 over 1. And what's your y-intercept?
3.
At 3, okay? So I'm going to go up to 3. And I'm going to draw my line negative 1, negative 1, negative 1. Right? And if I draw my whole line, just so I can make sure I understand what I'm looking at, looks something like this. Agreed?
Mm-hmm.
Okay, what are the parameters? What is this? What does the second thing tell me? I want where all the numbers in the x-axis are what? Greater than 0. So look again. Draw your line, your division line. This is where x is 0. Now, which side of my pink line are the x values greater than 0? On the right, the positive side. So this is the part of the line that I want. What do I do with the other part? What do I do with the other part? I erase it. I don't want it. And what kind of a dot should I have at this point?
Close
closed because we're equal to. So your piecewise graph is always going to look like a bunch of pieces of lines or parabolas or something like that. But it's important that you guys pay attention to what the parameters say. You have to understand that you are looking at the x-axis. It's where the x values are greater than or less than whatever number is given there. You're going to be looking left to right. Let's do this one here. All three are lines, yes? Yes? Yes or no? Yeah, they're all lines. Let's pick three colors. We'll do pink. The first one I'm going to say x plus 3. What is my slope and what's the y-intercept? 1 over 1. And my intercept is at 3. So I'm going to go, we'll just do it here. 59. Intercept at 3. My slope is 1. Is this a positive line or a negative one? It's positive. Yep.
Did you skip?
I did. Yep.
Was there a problem with it?
No, I just don't want to do it right now.
Okay.
I have other stuff I need to get to. But thank you for asking. Less than or equal to 0. Where, guys, is x equal to 0? The middle. Don't say the middle. Where is it? Right? The y-axis? Okay, so I want all the numbers where x is less than or equal to 0. Do I want everything to the left or everything to the right? To the left. So I want this part. What do I do with everything else? I'm going to erase it. Good. What kind of a dot do I have at this point? What is it? Closed. Good. Good, 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 good. All right, my second line. Guys, f of x is a fancy way of saying what? Y. So this really says y equals 3. Remind me again what y equals 3 looks like. Y equals 3. So I'm going to go to 3. And it's a horizontal line. Good. Yes, sir.
Can you go back to 59 just so I want to finish talking something?
Oh, whoops. I'm supposed to be on 59. My bad. There's my horizontal line. And I want the values on the x-axis that are what? What do my parameters say here?
Less than 0.
In between what?
Less than 0 and greater, or less than or equal to 2.
Okay. So what are the two? Where am I looking, guys? Between what two numbers?
0.
Between 0 and 2. That's all I care about. Between 0 and 2 on the x-axis. Right? Do you guys agree with me that those two parallel lines are 0 and 2, your parameters? So I want everything in the middle here. What do I do with everything else? I erase it. I just want that piece of that line.
Do you have 2 dots?
Why can't I make this smaller? Okay. I did it at 0 because my parameters were between x is 0 and x is 2.
But doesn't it say that 0 has is x is greater than 0? So it has to be greater than 0 for like the number?
For this piece of this line. Now we're looking at the second one. That those parameters will create an entire graph. Just depends on which equation that you're looking at when you go to evaluate.
Isn't the second one for the second line? The one. It says 0 is greater than x. X is greater than 0.
So what they're saying, because this is continuous, what they're saying is if I were to give you 0, if I said evaluate this where x is 0, which equation would you put it in? Which expression? Would you put it in the top one or the second one?
X is greater than 0.
If I gave you 0, if I said, Andrew, evaluate this where x is 0, which expression would you put it in? The top one, the middle one, or the bottom one?
Oh, so you choose each one?
You don't choose. Where does 0 fall in those parameters? Is 0 less than or equal to 0?
Oh, the first one, yeah.
Right. So this is just like those ones that we gave you yesterday to evaluate. This is how you would graph it. So if you plugged something in, if you plugged in 0, it would fall on the pink part of the line, not the blue part. If you plugged in a number that was less than 0, your answer would fall in the pink part of the line, not the blue. That's what that's telling you.
Oh, okay.
So then the last line that we have is 2x minus 1. So we'll do that in green. 2x minus 1. What's the slope for 2x minus 1? 2 over 1. And what's the y-intercept? Negative 1. So at negative 1, just kidding. Negative 1. And then my slope is 2. Is this a positive line or a negative one? Positive. So I'm going to go up 2 over 1. Sorry, I'm still getting used to this explain everything thing. So at negative 1. Okay, up 2 over 1, down 2 over 1. So my line is something like this. And these parameters tell me the only thing that I care about is where the x values are what? Bigger than 2. So go to where, draw your line. Here's my green line. Where are the values of the green line where are the x values greater than 2? To the right, over here. So then what do I do with the other stuff? I erase it. So there's your piecewise function. Do you see how it's just pieces of each line? It's always going to look interesting like that, we'll say. So all you're doing is you're visually graphing. If I told you to algebraically evaluate this piecewise function at -4, 1, and +6. When you plug in -4, you'd get something on the pink line. When you plug in 1, you'd get something on the blue line. And when you plug in 6, you get something on the green line. You're visually showing that. Yes, sir?
Okay, I'm slightly confused only because that looks a little bit off, because it's 2 over 1, right?
Hmm?
It's just because she graphed it on -2 instead of -1.
It looks like one. It looks like the line should be moved up just 1 only because it's technically by 2. It looks like it's by 1.
Yeah.
You see the little point where it's
Okay.
1, 1, and then there's the next one that's
Let me just move it a little bit.
Yeah.
Sorry. No, it's okay. I'll move it a little bit. Like here-ish.
Yeah.
Okay. I got a little sloppy. I apologize. Is that better? Okay.
For that line, does it matter if you put a closed or open circle?
A lot of times it's not going to matter because look, do you see how it includes at some point? You see how this is at 2 and this is at 2? It's like our interval of increase and decrease. You can't increase and decrease at the same time, so that's why it's always, if it's continuous like that, it's not going to really matter. We're going to have to wrap our brains around that. I know that. But that is not something that's just going to go away, so we have to practice it. Let's go on to this last bit, and then we'll be done, and you guys will have some practice time. We're going to talk about odd, even, and neither. There's 2 ways to talk about odd, even, neither. It's algebraically or graphically. Graphically, it's real easy. Okay, all of this stuff in here is what I wrote over here. Feel free to read this about negative x, negative y, graph, symmetry, blah, 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 blah. This is what you need to know. Graphically, if a function is even, think about even. Even, 2, 4, 6, 8. We like even. I like even numbers. Even functions, the arrows of the graph go in the same direction, and it's symmetric to the y-axis, meaning you can fold it over the y. If a function is odd, the arrows go in opposite directions. Think about that, odd, opposite. And it's symmetric to the origin, meaning the graph actually goes through the origin. It has to do both of those things. So if I look at this picture, first of all, tell me, which direction are the ends going in, or the arrows? They're both going in the same direction or opposite direction?
Opposite.
On letter A. Are they both going up? They're both going down. They're both going up. So they're both going in the same direction. Can I draw a line through this on the y-axis and cut this thing in half, is the mirror image. This is symmetric to y. That means it's what kind of a function? Even. If it does both of those things, it's even. Look at B. Look at the directions. Look at the ends of the graph. Are they going in the same direction or opposite directions? Okay, they're going in opposite directions. Does this graph go through the origin? Yes. So if the ends are going in opposite directions, and they're both going in opposite directions, and the graph goes through the origin, what kind of a function is this? Odd. Good. Look at C. Point out those two things. Which direction are the ends going? They're going in the same. So if this was an even function, direction of the arrows is the same, and it has to be what? Symmetric to y. Draw a line on the y-axis. If I cut this parabola right there, is it half on one side, half on the other?
No.
So this is what?
Not neither.
Neither. Not symmetrical, whatever. Odd, even, neither. Graphically, this is really easy to tell. What about D? Which direction are the arrows going in? The same. Good. If I cut it in half right down the middle, what happens?
Symmetric.
It's symmetric. That means this is what?
Even.
This is an even. Good. One more thing to show you. Did you just sneeze? Bless you. Okay, look at this one I just drew over here. Look at the ends. What are the ends doing? Opposite. Okay, so opposite. Does it go through the origin? So this is what? Neither. Good. Now, algebraically, this is similar to symmetry, the way that we're going to do this, but I'll show you a shortcut or something I think is a little easier. If you plug in a number and its opposite, if you get the same answer, it's an even function. If you get opposite answers like -6, +6, then it's odd. If you get completely different answers, it's neither. So what I mean by that, let's do 65. Everybody pick a number. Not bigger than 1.
3.
Okay, 2 and 3. Pachas do 3. We'll do 2. Do this with me, all right? Just pick a number bigger than 1 is what I meant. So you have 2 and -2. So I have my function 3x minus 2, 3x minus 2. All right, so I'm going to plug in +2 over here. So I'm going to say 3 times 2 minus 2. What's 3 times 2? 6 minus 2 is 4. All right, now I'm going to go on the other side, and I'm going to plug in what number? -2. So 3 times 2 is -6. -6 minus 2 is -8. Look at the relationship of these two answers. Are they the exact same? No. Are they opposites of each other? +4, -4. +8, -8. No. They're two totally different answers. Yes? So what kind of a function is this? Neither. Because guys, look. This is a line, correct? 3x minus 2 is a line. If something is a line, what happens to the arrows at the end? They go in opposite directions, right? So in order for something to be symmetric, something to be odd, the direction of the arrows is opposite, but it has to go through the what? Origin. If I have something that's -2, that means it moves down 2. This doesn't go through the origin. Let's look at 67. Look at 67. What does 67 say? X squared minus 4. Pachas, did you get the same answer? That it was neither?
Yeah, I got different.
Okay. All right, somebody pick a number. 5. Let's do 5 and -5. Somebody else, Sean, pick a different number.
7.
Okay, you do 7. All right. So I'm going to say 5 squared minus 4. What's 5 squared? 25 minus 4 is 21. Agreed? All right, now I'm going to plug in -5. Remember, it's negative. It needs a hug. What's negative 5 squared? 25. What's 25 minus 4? What do you notice about those two? It's an even function. They're the same number. What's another clue that this could possibly be an even function? Doesn't mean it is, but it could possibly be an even function. This squared. What's a clue that this could have possibly been an odd function? What's the exponent on 3x?
1.
Just 1. If you have an even exponent, it's either going to be even or neither. If you have an odd exponent to the first power, third power, it's either going to be odd or neither. But algebraically, it's real easy to figure out. What the book wants you to do is plug in negative x, positive x, and negative x, which you'll get the same answer, but it's, to visually see it, especially for you guys, it's easier to just plug in numbers, because then you get a number answer. You're not dealing with letters. You can pick any number you want. You know, so somebody always gets cute and they're like, I'm going to do 5,000. Okay, fine. If you want to square 5,000, have at it. I would just pick 2 or 3. It's just easier. But if you want to change it up a little bit, 4, 5, whatever. Just, it has to be the number that you pick and its opposite. That make sense? Okay. I will upload this video in a little bit.